Okay, so let's get started. We're going to be taking a look at our optimal power mode for our VCT scheduling in our Gen 3 Coyote engine tuning. Now, the optimal power mode is going to be what we enter in full throttle conditions. This is where we command a richer target lambda mixture to get better performance out of our engine. We also command a more aggressive variable cam profile out of our variable cam scheduling so that we get the best, broadest torque curve possible out of our engine. So we're going to learn how this works, how we enter it into the optimal power mode, and we're going to take a look at a data log so we can see a sample wide open throttle pull on a stock engine so we can see what we're comparing against and taking a look at some of the scheduling that goes on, and then just understanding just overall how this works. It's a pretty simple concept, but it's definitely something that we want to keep track of and understand because we want the best performance out of our engine under higher throttle, full throttle conditions. Okay, so the first thing I want to do here, moving into our VCM editor software, have that open on my laptop screen. I'm going to go up here to File Open, and we're going to move into a stock equivalent file so we can take a look at our VCT scheduling, specifically with the optimal power. Now, I'm going to select the 2019 Mustang GT manual stock file. Any stock file will do, but I'm going to go ahead and open this particular stock file up. This is what we've been using in the last few training modules. Now, we're going to move here into our Engine tab. We're going to go under General, then we're going to move over here to Airflow, and then finally under Variable Camshaft. So here's where we find all the variable cam programming for our VCT scheduling. Now we know how this works. At this point, we went through a couple tutorials now looking at the VCT scheduling, so we know we have our intake opening and exhaust valve closing events that were scheduled through what's called mapped points. The mapped points are called out in our distance tables. We have several different distance tables that we work with for our engine's normal operation. That's going to be optimal stability for idle and overrun decel conditions. Then we have our best fuel economy, which is used for part throttle cruise, best drivability, which is used to transition into more performance-oriented type of cam pairing. And this is what we call on right before we move into what's known here as optimal power. So the optimal power here is found in this particular section. Now, let's talk about a few things here. Let's talk about how this actually works. We're going to be touching on some of our fueling with optimal power, how it switches over to a mode called optimal power for our fueling delivery, and then we'll also talk about our VCT scheduling. So I quickly want to just move off of our airflow window here and go over to fuel, and we're going to notice we have a tab here called Power Enrich. Power enrichment is optimal power mode. This is what we enter into when we get into high enough throttle and high enough load output out of our engine. We want to go in and richen up our target lambda mixture. Now we're going to cover this topic in another tutorial, but we're just touching on this right now because when we enter into power enrichment optimal power, we should see that our command at lambda here, our watt lambda, goes from stoichiometric to whatever we're commanding here in our watt lambda table. This is our new lambda target under full throttle. So we can see here we do have some conditions to meet: our throttle, the enrichment, the pedal position to enter in here. We typically want to go in and change this up a little bit. So this pedal position versus RPM table matches what we're commanding in our optimal power under our VCT scheduling. So let me go in and demonstrate this real quick. Essentially what this is doing is translating your Excel pedal position input to a RPM threshold to enter into this optimal power, again, to go and richen up our target lambda mixture so that we're running the engine in a more oriented lambda mixture to get the best torque and horsepower out of our engine. So let me go in and configure this real quick. So if we go in here and right click and we go in here to row axes and we go here to edit, it allows us to go in here and edit the engine RPM over on the left axis here. So what I'm going to do is change this up a little bit. I'm going to set my first data point here to 1,000, then we can go to 2,000, then we can go to 3,000. You can change this to whatever you'd like, but this is pretty standard going in here and touching this up. So I'll go here at 6,000, and then we'll put one here finally at 7,000. Okay, so now we have an engine speed defined on our axes. So instead of just setting it at 6,500, we're setting it between 1,000 and 7,000 RPM. Now, the next thing we're going to do here is change the pedal position to enter this richer target lambda mixture mode. So what I'm going to do here is set this at 1,000 RPM. I'll say something like maybe 70% throttle, and 2,000 RPM, maybe I want to be at 60% throttle, 3,000 maybe at 50% throttle, 4,000 maybe 40% throttle, and then 5,000 and above, I can say something like maybe 30% throttle. This is going to be where we transition into that higher, richer target lambda mixture called out here for the watt lambda table. So this is important to understand because, again, when we go full throttle, we need to command a richer lambda mixture so we get the best performance out of our engine when we're going into what they're calling power enrichment, or in this case, optimal power mode. So this is what we do on the fueling side. Now, let's translate this into the variable cam scheduling. So what we're calling out here for pedal position also coincides to where we're calling out the optimal power VCT scheduling to be drawn on. So we want these two tables to match. The pedal position for our fueling enrichment right here should match our VCT scheduling pedal position to enter into the optimal power under the VCT scheduling, because we want them to sync together, and we want them to, if we're running the more aggressive cam profiling, we want to also draw on the fuel so that we take advantage of this. We don't find that we're running lean if we're transitioning over into a more aggressive VCT scheduling. So this just makes the most sense to tie these together. So we've updated this table here. What I'm going to do is jump back under airflow and jump back under variable cam. So under optimal...
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.